Hello guys, here in this particular video we will learn the numerical, that is problem based on negative feedback amplifier. In this problem we have to find out first topology, perfect for topology of negative feedback amplifier. Then second step is find out the circuit without feedback, and the third step is whatever finding which has been asked in this particular numerical. The numerical is there on your screen. The circuit comprises of two MOSFET, which is named as Q1 and Q2. RD1 and RD2 are nothing but the drain resistance for stage 1 and 2 respectively. R1, R2 comprises of the feedback circuit. Here I can observe that the feedback is taken from the drain side of the second stage amplifier. That is, the output voltage is sampled and it is given to the feedback circuit through R2 and R1, and this feedback is mixed in series with the input signal Vs. So now here we can say that we have to start with the finding the topology of negative feedback amplifier. So first of all we'll have to learn that whatever the values which are given, whatever values which we have to find out for the finding the values whichever they have asked us, and then we will move further for the solution of this particular numerical. Given quantities Gm1, Gm2, that is nothing but the transconductance of the particular transistor amplifier, 4 milliampere per volts. RD1, RD2 having same values, that is 10 kilo ohm. R1 having value 1 kilo ohm and R2 having value 9 kilo ohm. Now we have to find out the value of input resistance with feedback, output resistance with feedback, and the value of gain with feedback. Okay, so here hidden value which has been given as AVF, which is giving little bit idea about the topology of negative feedback amplifier. So in such numericals somewhere you will find the hidden values which will give you some negative feedback topology. So we'll move one step ahead, that is your first step to find out the negative feedback topology. Step number 1, we have to find out the negative feedback topology. For that we have to learn this circuit. So we'll have to do the analysis of this circuit, not mathematically, logically. Output voltage is sampled. As I said you that the output voltage is sampled, that means the sampling is of the type voltage. So if the sampling is of the type voltage, then obviously the circuit consisting at the output side for the feedback and forward loop gain amplifier is nothing but the shunt circuit. Okay, so here I will note that at output voltage is sampled, hence sampling is of the type voltage, and this is also called as shunt sampling. So in bracket I'm writing it as shunt because the circuit is looking like shunt. Okay, next we'll have to move ahead at the input side. So we have identified that what is the sampling parameter and what is the circuit at the sampling part. Now we'll have to learn what will be the mixing phenomena. In the mixing phenomena I'm getting that Vs is nothing but the addition of this Vi and this Vf that I'm getting as a feedback voltage. So I'm saying that this Vs is the addition of Vi and Vs, that means it's nothing but the series mixing. So here I will say that here voltage parameter is mixed with the input signal as voltage only. So I can say that hence it's a mixing. So we'll write mixing is of the type series mixing, and the parameter I'm writing it as voltage. Now from these two few words I'm getting that the feedback topology is nothing but voltage series negative feedback. Okay, now it is also called as series shunt negative feedback topology. So I can say the conclusion of the step number 1 is the topology used is nothing but voltage series, or it is also called as series shunt. At the first name, sampling mixing, and for the second name, mixing sampling. So this is our conclusion as far as the first step is considered. Now we will move ahead for the second step, that is nothing but to draw circuit without feedback. Now in that case we have two subsections. One is feedback circuit and B section is circuit without feedback. With feedback circuit we'll be finding the value of the B, right? So B, and then circuit without feedback, there we'll be getting the value of Ri, AV and RO. As earlier I gave you the information regarding the hidden value which has been given in the numerical. So as I have discovered that yes, my topology is nothing but voltage series amplifier. So in voltage series amplifier, the parameter at the output side is voltage and the parameter at the input side as well voltage. So whatever the ratio of the output parameter I'm getting, ratio of the gain I'm getting, that is nothing but voltage gain. So only whatever given is nothing but the hidden part with which we can get what is the feedback topology. Now let's move ahead to find out the feedback circuit. So I will draw just this particular feedback circuit and I will say that this is nothing but the feedback circuit. I am marking with dotted line where this is your output voltage. We have to find out the value of B, right? So I will draw this circuit here again. This is the value of R2, this is the value of R1, whereas the value of R2 is 9K and the value of R1 is 1K. Here I am getting the value VO and here I have the value VF. For the B value, B is nothing but, we'll say for voltage series circuit, we will be getting B is equal to VF divided by VO. We will be getting that ratio by using VDR, that is voltage divider rule. So this ratio will come out to be VF divided by VO is equal to R1 divided by R1 plus R2. This is nothing but 1K divided by 9K plus 1K, and that is nothing but 0.1. This is the first finding with which I will move ahead further for the particular finding whatever they have asked us. So I will note this as equation number 1. So let's move ahead to find the B part of this particular step, that is circuit without feedback, to find out the value of Ri, AV and RO. Now as I said earlier, to develop the circuit without feedback we have to do some modification in my circuit, right? So if there is the voltage sampling at the output side, I will do the short circuit to form input side of the circuit without feedback. What we will do, we will short circuit at the output voltage. If we short the output voltage, R2 and R1 become parallel in nature and it will be connected to the source of the first stage of the amplifier. So I will draw this particular circuit at the input stage, then we'll get a clarified. This is your circuit at the input side. Whatever I'm getting, rest all the things will be as it is. So this is your input Vs with respect to ground connected to the gate of the first stage, and whatever emitter side I am modifying, that is nothing but the combination of R1 and R2 parallel in nature. So here this is being done by short circuit at output, that is VO. So I will say that it's nothing but VO is equal to 0 volts, then only then it is possible to have R1 R2 in parallel combination. Now I will modify at output side. At output side, what we'll have to do? At output side, as this is the series connection, I will open the feedback connection because I want the circuit without feedback, so there should not be any interference of the feedback with my amplifier. So I'm taking this disconnection from the source side, so I will be getting R2 and R1 in series connection at the output side, that is at the drain side of the second stage. So I will draw the particular circuit based on that. I'll mark it with red pen so that you will get an idea that this is your modified output stage. And this has been done by open circuit at input. So I will open the source side of the first stage, then I will be getting the disconnection of the amplifier, that is forward amplifier, and the feedback block. So this is how we'll have to modify at the input side and output side. Now we will draw the combined form of the circuit without feedback. This is the circuit without feedback. Wherever RD1, RD2 is placed, I will keep it as it is, and wherever your modification is there, I have kept with the red ink. Okay, so whatever circuit I have, I will convert this into AC equivalent model. Rather than that, instead of drawing that complete AC equivalent circuit, we know that my circuit is with GM1, GM2, VGS1, VGS2, which has been open circuit at the input side of each stage. So just that, keep that particular things in mind. Not necessary to draw that AC equivalent circuit. If you have drawn it, it's better. If you have not drawn it, it's well and good. You can directly go ahead for the calculation. So let's move ahead for the calculation part. If I want to find out the value of the voltage gain, so the first parameter, we'll write this as step number 3. Step number 3 is to find AV, RI and RO. Once we get the AV, RI and RO, we'll have to find out AVF, then ROF and RIF by just multiplying with the desensitivity factor or dividing by desensitivity factor according to that particular topology. So let's concentrate on the AV. So AV, how to find out the value of AV? AV is nothing but VO divided by VS for without feedback circuit. So all the calculations whatever we are going to do, that will be without feedback circuit. Okay, this is the circuit with which we will do the analysis, complete analysis. Then we will be getting that VO divided by VS is divided into two parts. One is AV1 and another is AV2. Okay, so first of all we'll have to get that what will be the value of AV1. AV1 is nothing but the voltage at the output of the first stage and the input of the first stage. That is, let's say this is nothing but VO1. So VO1 divided by VS is nothing but the value of AV1, and we'll have to find out what will be that particular value. I know that the value is coming out to be GMRD divided by 1 plus GMRS. So you have to have the knowledge about the all formulas regarding the CS or C, whatever transistor we are using. So GM1 I'm using because first stage GM1, this is your RD1 divided by 1 plus GM1 into RS1. So what will be that particular value of RD1? As RG is not specified, we don't have to consider the input resistance of the second stage. So only RD1 will come into picture. So what will be the value of RS1? RS1 will become parallel combination of R1 and R2. R1 parallel R2. GM1 and GM2 already we have So we'll just calculate what will be that particular value of R1 parallel R2. So R1 parallel R2 is coming out to be 0.9K. So RS1 is coming out to be 0.9 kilo ohm. It is nothing but your 900 ohm. So just calculate with this particular RS1. I'll put this value of RS1 over here. RD1 is nothing but RD1 is equal to 5K, which has been given. GM1 is also given, that is 4 milliampere per volts. So what we will be doing, we'll just put the value of GM over here, we'll just put the value of RD1 over here, and we'll just put the value of RS1 over here, so that we will find the actual value of AV1. So that work you have to do. So calculate that particular value of AV1 and come to me. So let's move towards the value of the AV2, that is nothing but the gain of the second stage. So let's compare the first and second stage. Here you will find that there is the source resistance available, but here source resistance is not available. So this will be the simple calculation for me, R1 in series with R2, and that complete combination will be in parallel with RD2. And as your RO value, that is RD value, output dynamic output resistance value, is given as infinity, dynamic resistance value which has been given as infinity, so that will be open circuit. So I can say that the value which is coming out to be is nothing but minus GM 2 into RD2 in parallel with R1 plus R2. This will be the simple calculation that we have to do. I know that what's the value of GM2? GM2 is nothing but 4 milliampere per volts. RD2 is nothing but 5 kilo ohm. R1 which is been given as 1K and R2 which has been given as 9K. So in all, by addition, we'll be getting 10K. What we'll have to do? 5K in parallel with 10K, then multiply it with 4 milliampere per volts. So that also you have to do. I left it for you. AV1 multiplied by AV2, that is nothing but your actual gain of complete feedback circuit without feedback circuit. So whatever AV that I'm getting by calculation, AV1 multiplied by AV2, that I'm getting as 173.9, and I will treat this value as equation number 2. Now we will move further for the simple calculation from the circuit itself. What will be your input resistance and what will be your output resistance? So tell me what will be your input resistance. I'll get from this particular circuit itself. I know that the gate and source connection is open circuit. So ultimately your input resistance is infinite, right? So whatever value at the input resistance I will be getting without circuit as well as with feedback circuit, then that will be your infinity only. Let's move ahead for the output resistance. Output resistance without feedback, that is nothing but RO. RO is nothing but, as we have considered, RD2 in parallel with R1 in series with R2. That particular combination, whatever I'm getting, that will be your RO. And if we divide it by the desensitivity factor, that will be getting the resistance, output resistance with feedback. Okay, so let's move for the particular calculation. We'll write it as input resistance. Input resistance is nothing but Ri, which is nothing but the infinity. Let's move ahead for the output resistance. I will show it over here because we are using the AC analysis. This is your VGS1 which has been open circuit, and whatever RS1 I'm getting, so there will not be any current flowing through RS1 which is of the part of the input side. So I will not consider this as the resistance of at the input side. So whatever resistance at the input side I'm getting, that Ri will be infinite. At the output side, output resistance, that is RO. RO is nothing but RD1 in parallel with R1 plus R2. Very simple calculation, straightforward calculation I will be getting. So if we draw that particular AC equivalent circuit, here we'll be getting the value of GM2 and VGS2. Here we'll be getting the dynamic output resistance, which is having value infinity, and then after we'll be getting the value of RD2, not 1. So instead of RD1, RD2, both values are same. So as far as calculation is concerned, you will not get any wrong answer. RD2 in parallel with the series combination of R1 and R2. So this is how we will be getting the value of RO. Okay, so RO is nothing but RD2 in parallel with R1 plus R2. Let's find out that particular value. RD2, we know that the value of RD2 is 5 kilo ohm, I guess. That value is nothing but 10 kilo ohm. It's my mistake. It's given as 10 kilo ohm. Whatever value we have got for 1K and 9K addition is nothing but 10 kilo ohm. So put that value, we will be getting the RO as 5 kilo ohm. All these values that we have got are nothing but the for circuit without feedback. So I'll treat these values are the values without feedback, and our intention is to find out the value of the parameter with feedback. So let's move ahead. For voltage series topology, we will write it as for voltage series feedback topology, AVF is equal to AV divided by 1 plus AV into B. So whatever value I will be getting, AVF is equal to open loop gain, that is without feedback, divided by 1 plus open loop gain multiplied by B, which is nothing but 0.1, which we have calculated. Then value, we'll find out that particular value, check your KLC is working or not, and then come to me. Value of RIF is nothing but RI multiplied by 1 plus AV into B. Already we have Ri is equal to infinity, so this part will become infinity only. What's the value of ROF? ROF is nothing but RO divided by 1 plus AV into B for voltage series negative feedback topology. So all these multiplication or division, that depends on the particular feedback topology. Here we are considering, here we have the example of voltage series negative feedback topology. So according to that, we will just multiply and divide for particular parameters. So RO we have got as 5K. This is 1 plus AV, which we have got as 173.9 multiplied by B, that is 0.1. So let's find out, check your calci is working or not, and then come to me with the value of AVF and ROF, because RIF already we have got as infinity. AVF that will be getting as 9.46. No unit because voltage by voltage ratio, and ROF that will be getting 272 ohm. So these are the particular values which are expected as answer. So I will treat this as answer part, and we will conclude that we have got the voltage gain which is less than open loop, that is gain without feedback. RIF which is already infinity, that will be infinity only. ROF that is nothing but 272 ohm, which is decreased by applying the feedback circuit. So we'll conclude here for this particular numerical. Learn more and more EDC along with me, along with Ekeeda videos. Subscribe this channel of Ekeeda videos. Thank you so much.